On-the-job training is a useful method for learning new competencies and skills required for a job in an actual working environment. The goal is to develop existing skills and acquire new ones, practice theories learned in school, and understand a company's culture. Good day, everyone. I am Kassandra Mae Banaag, a civil engineering student who's to share my 300-hour OJT experience at DL Cervantes Construction Corporation. This presentation aims to provide a detailed summary of my OJT experience from June 3 to July 16, 2024. It was divided into 4 chapters: the company profile, OJT activities, technical and soft skills learned, and engineering problem, and the conclusion and recommendation. And to begin with, let me first introduce the company that welcomed me. Construction has always been a significant industry in developing countries like the Philippines. Traditional building and management practices are unable to keep up with the rising need for technical complexity due to steady economic expansion. To meet this demand, Mr. Diosdado L. Cervantes established D.L. Cervantes Construction on March 1, 1991. D.L. Cervantes Construction Corporation, or DLCCC, is a construction corporation with a head office located at General Marvel Street, Binyan, Laguna. Joining at the helm of DLCCC is Mr. Cervantes' son, Engineer Juan Paulo M. Cervantes, who is a visionary leader with strong curiosity and adaptability. Mission and vision statements help businesses outline performance standards and metrics based on the goals they want to achieve. For DLCCC, the goal is to build tomorrow's legacies today. Leaving a legacy means consistently delivering excellence through collaboration, efficiency, and an unwavering commitment to quality. With this goal, DLCCC aims to be a construction that shapes the industry, serves humanity, and stands the test of time. The company is driven by its passion for transforming dreams into reality, forging lasting relationships. Quality, integrity, people, continuous improvement, and teamwork. DLCCC aims for excellence, does the right thing in every situation, values employee safety, growth, and development, embraces change for the good of the organization, and does everything in unity to achieve a common good. Known for delivering quality products, projects, and services to its valuable clients for the past 3 decades, DLCCC is categorized as a AAA contractor in general engineering and general building. Also, it has an ISO certification, which means the organization has put in place effective processes and trained staff to deliver flawless products or services time after time. For 33 years, DLCCC has completed different kinds of construction projects ranging from excavation works, road construction, gymnasiums, and housing to commercial buildings. They also offer rentals for heavy equipment. Today, DLCCC has completed almost 200 projects and still has ongoing projects nationwide. Colegio de Muntinlupa, Museo ng Muntinlupa, Ospital ng Muntinlupa, and Muntinlupa Sports Complex are just some of DLCCC's completed projects in Muntinlupa City. The OJT program has been an effective training and learning method as I developed knowledge, skills, and values, especially in the field of civil engineering. The training took place at DLCCC's ongoing project, UniHealth Southwest Hospital and Medical Center, located at Sama Avenue, Molino Farbacoor, Cavite. So the video on the left side was filmed during the first week of my training, while on the right side was during my 7th and last week. Being trained at a construction site, I got to experience the workplace where I want to be in the future and the job I might do someday. This pie chart summarizes the activities I've done during my 300-hour training. It was shown that we often do inspections, estimations, and meetings. Before the activities flash on the screen is the organizational chart of my assigned department. Engineer Gerald Garcia is the project in charge of UniHealth Southwest and also my supervisor. For the process of masonry and plastering estimation, a key plan is important. Here I showed a specific part of the key plan I did. Based on the format given by my supervisor, Green lines represent internal M2 panel walls with 100 mm thickness, and blue lines for external M2 panel walls. From the key plan, I created a 2D elevation of all the walls in every floor I was assigned to. Dimensions placed were important for the M2 panel cutting case. So M2 panel is a lightweight and cost-efficient alternative to CHP. It is made up of two galvanized welded steel wire meshes joined by connectors that enclose an expanded polyester panel. For the UniHealth Southwest project, the majority of walls will be made up of M2 panels except for electrical rooms and operating rooms, which will be made up of CHP and reinforced concrete respectively. The first table shows how the total area of masonry was computed. So the rectangular area of each wall was first taken, then the total area of windows, door windows, columns, and beams that were on the wall was determined to be subtracted from the area. While the second table shows how the total area of plastering was computed. So it was divided into two categories, the smooth and rough finishing. Smooth finishing will be for the majority of walls except for the comfort room and toilet and bath, in which a rough finishing will be used. Next activity is concrete pouring. But before that, the steel reinforcement and formwork must be inspected first. So for concrete pouring, once the concrete mixer truck arrives, the concrete must be checked for quality assurance. The concrete's temperature was first checked where the result must be below 32 degrees Celsius. For slump test, a slump cone was filled with 3 layers. Each layer was stamped 25 strokes of the tamping rod to make sure the concrete is well compacted. After removing the cone, the slump was then measured, where it must lie between 6 to 8 inches depending on the concrete mix design. Then concrete cylinders of standard size were filled with concrete. Same process of filling to slab test. The samples were then placed into a safe place to be tested after 7, 14, and 28 days. There were three methods of concrete pouring witnessed: the crane and bucket method, which was shown in the slide, the concrete and the line pump method. After every batch of pouring, the concrete was spread using a shovel and tamped using either a tamping rod or vibrator. For compression test, each sample was weighed and diameter was measured using a caliper. After setting up the sample to the compression machine, the test will start. During the test, different patterns of cracks were developed, and after reaching the maximum compressive strength, which value will appear to the machine, the test ended. Next activity is grouting. Grout is a dense fluid used to fill gaps and honeycomb in concrete. Sika grout, a specific grout used in the project, has two types: Sika grout 212 and 215. So 215 has higher compressive strength than 212. That is why it is being used in column-based grouting, while 212 is used to fill in honeycombs in concrete. For the process of grouting, the grout powder was first mixed with water for 3 minutes. Then during the resting time, concrete cube molds measuring 100 by 100 millimeter were filled for compression testing after 7, 14, and 28 days. Next is the inspection of tightening of high-strength connection bolts. These bolts have a required tightening torques, which is determined to be reached using a torque wrench. So in every connection, 10% of the total number of bolts were randomly chosen to be tested. If the torque wrench made a sound, that means the bolt reached its corresponding moment, while if not, the bolt needs to be tightened up more. Then the inspection of column alignment, where total station was utilized in this inspection. Lastly, for the site inspection, every step of work done was examined. For steel reinforcement, spacing of rebars and concrete cover were measured, and all intersection of bars were checked if there are bar ties applied. For formworks, dimensions of phenolic board and concrete cover were measured, stability of forms ensuring for slab were checked, and they looked if there's an existence of gaps or holes. For basement tanks, retaining wall, and other part of the structure exposed to water, the stability of water tap installed were also checked. For backfilling, The size of rocks were examined and hardened concrete, if any, were marked for chipping. After 300 hours of being on a construction site, witnessing and experiencing an actual job, I acquired and developed different knowledge and skills. One of those is the process of estimation, where I was able to apply the skills I acquired from different subjects at school. For example, in making the key plan, 2D wall elevation, and cutting list, I was able to apply the basics of AutoCAD I learned from my previous subject, computer-aided drafting. For estimation where Microsoft Excel was utilized, it became easy for me to create and manipulate formulas with my experience using the software for our final project in engineering data analysis. For the framework and rebar estimation, though complete details and instructions were provided, knowledge cultivated from quantity surveying played an important role in my easy understanding and finishing the task. Another thing I learned is the basics of Lumion and PlanSwift for 3D rendering and quantity takeoff, respectively. An important skill and job of a project engineer was also which is contract billing. The specific billing I learned was for the subcontractor of formwork and rebar. I also acquired basic skills in utilizing materials and devices such as caliper and total station. In addition to technical skills, I've learned the importance of various soft skills. Teamwork enhances project outcomes, reduces injuries, and improves quality by leveraging diverse expertise and effective communication. Problem-solving skills help navigate projects, ensuring safety and efficient resource management. Effective communication ensures smooth collaboration among professionals, reducing costly mistakes. Adaptability is crucial due to changing project requirements, evolving technology, and climatic conditions. Critical thinking allows engineers to evaluate complex problems and develop innovative, safe solutions. Time management ensures project deadlines are met, budgets are adhered to, and resources are optimally used. Interpersonal skills are vital for building trust, resolving disputes, and ensuring project success by effectively communicating with clients, contractors, and other stakeholders. Engineering problem is a challenge or issue that requires applying engineering principles, techniques, and tools to develop a solution. It typically involves identifying a specific need or constraint, analyzing various factors, and creating a practical and efficient solution to address it. That is why my objectives are to discuss the engineering problems I encountered and to propose possible solutions while considering factors such as safety, cost, and performance. Engineering problem solving is vital because it drives innovation, improves efficiency, and ensures safety across diverse fields. By tackling complex challenges and optimizing processes, engineers develop new technologies, enhance productivity, and create more sustainable practices. Their solutions not only address immediate issues, but also contribute to the resilience and adaptability of systems, ensuring that they remain functional and effective in the face of changing conditions and unforeseen problems. This critical approach supports both progress and the practical application of engineering principles in real-world scenarios. The common problem I observed is the construction delays caused by weather conditions, scheduling conflicts, and communication problems. Unpredictable weather conditions, particularly during my last weeks, halt construction activities, especially during heavy rain. Inefficient scheduling results in workers waiting around for materials and approvals. Lastly, poor communication among stakeholders leads to misunderstandings and mistakes. Common communication problems are misinterpretation of information, delayed information flow, inconsistent reporting, and lack of coordination. One specific example of a communication problem is the mistake with the spacing of viewers in the file tab. So it was supposed to be 200 mm on center, but it was 300 mm on the PDF file and printed plan and details. That cost them a lot of money and time that would have been spent on other activities. They even blame each other for that mistake. Engineering problems, specifically construction delays either caused by man or nature, can be solved by applying a systematic approach. Though sometimes these problems are uncontrollable, like the weather, it can still be mitigated. Solutions to mitigate weather delays could be accurate weather forecasting, flexible scheduling, protective measures, alternative work plans, and contract clauses. Mitigating scheduling conflicts and construction delays involves several strategic approaches, such as comprehensive planning, clear communication, resource allocation, contingency planning, monitoring and reporting, and risk management. Lastly, improving communication to mitigate construction delays involves implementing clear and consistent communication protocols, such as regular project meetings and updates using digital collaboration tools. Establishing a centralized communication platform where all stakeholders, including contractors, subcontractors, and project managers, can share real time information and updates ensures everyone is on the same page. Additionally, fostering an environment that encourages open dialogue and proactive problem solving helps address issues promptly. Clear documentation of project timelines, responsibilities, and changes helps prevent misunderstandings and keeps the project on track, ultimately reducing the likelihood of delays. Mitigating construction delays involve proactive planning, effective communication, and continuous monitoring. Clear schedules, realistic timelines, and advanced project management tools help anticipate and address challenges promptly. Enhanced communication among stakeholders ensures swift issue resolution and reduces misunderstanding. Regular progress assessments and flexible planning maintain project momentum, leading to timely completion, minimize cost overruns, and overall project success. Upon the completion of the 300-hour training, I was filled with intensive learning experience, better communication skills, ethical working values, and confident self-competence. Not only did I acquire technical skills, but I also had the opportunity to cultivate soft skills that would be very helpful for my professionalism and even personal life. While gaining knowledge and skills, I was also able to contribute to the company's need for assistance. The OJT experience would be so far the best learning experience of my college life. It was an eye-opener that showed me the bigger picture of what civil engineering is all about and what a professional workplace looks and feels like. These were all because I was assigned to the construction site where I experienced fieldwork and ops works. So for the institution, it would be great if the same experience will be given to all the upcoming trainees. The OJT program could be better and more effective if it also pushes the students to be exposed to the field they're taking.